Hello, I'm Li Hao. Welcome back. I hope that the build your own Svelte video is an interesting one. If you have not watched that video, feel free, click on the links on the corner and I will wait for you over here. Well, for those who have watched it, well, I hope you enjoyed that one. And as promised, following up from that video, we are gonna make a few more smaller videos talking about solving each small points, polishing up our compiler so that you can understand even more things about how you can build your own Svelte. So the video itself is more of a conference talk. It gives you a whirlwind kind of view about how you can build your own Svelte. But if you're really interested on building your own Svelte, I guess the devil is in the details. So in this video and the following videos, we're gonna look at specific things one by one, tackling to make our mini Svelte compiler even more powerful than we had. And also, of course, that talk itself, to squeeze all the content within that short period of time, I have to do a super fast typing using this extension called a hacker typer. But from now on in this video series, we're gonna do an actual typing, right? So this is more of an actual speed and we are going to actually building things piece by piece. With that, let's take a look at what we're going to look at today. So over here, this is the compiler that we have written over. If you want to know about the source code, it is on github/username tanhaohao/minisvelte. Right, so over here, we've built our Svelte compiler. And as I mentioned in the video, this is a contrived example. We only support what we have over here. It is by design because or else I couldn't fit in within the time frame of the whole talk. But looking at over here, let's do a very simple one, right? Say for example, if you want to say counter times 2 equals to counter times 2, something like this, right? And let's try and compile. And see whether it works. Let's take a look over here. It seems like it's partially works, but not really, right? This content is undefined. And if you try to, let me try and open another terminal, HTTP server. If you take a look over here, this looks almost as it is. You have the expressions, some text, and the expression over here, and decrement and increment works, except that this not good, right? Why? Well, because we kind of assume that all expressions are just identifiers, right? I'm not sure you pay attention so far because we really went through very fast. But we kind of assume that as we write, we were assuming that expressions are only identifiers. What is identifiers? Well, identifiers are like variables. So it's just variables, but not expressions. So what expressions? Expressions can be counter times something. This is an expression. This is an expression as well, but this is a identifier, right? This is a binary expression. You have something on the left, something on the right, and an operator, right? So it's a binary expression. So it wants to handle this binary expression so that it's more useful, right? I mean, we can't really always write just expressions. So to support that expressions over here, what we would need to do is that we will need to take a look at where we handle expressions. So here, expression, if we search for it, when we parse it, we parse with JavaScript, then it's okay. I mean, so it definitely can able to parse it. And then later on, when we expression, we traverse, when we find what will be used in a template, we use fragment.expressions.name. This is not that great because this assumes that this is an identifier and name is always the variable name, right? So if I come over here and add actually I don't need the brackets, but I come over here and console log fragment.expression, and let's try and run my code. Then you will notice, let me zoom in a bit more. You'll notice that it can be identifier and it can be a binary expressions, right? So binary expression in this case is it is an operator. You have the identifier, which is the variable, like the counter, and then some star and literal over here, right? So meaning we need to handle binary expressions as well, and also a lot of other expressions like call expressions and stuff like that, right? It might scare you a bit, but I mean, we can slowly expand that. So for now, what we can do is maybe we can extract this into a function called extract names. Oops, extract names fragment dot expression, and then for each. So this hopefully will return us an array of variables names, because over here if I do counter times name, something like that, then I want to return an array of counter and name, right? So this is to basically try to find all the variables that is within your expressions, right? So we close this. So we're going to extract names, and then for each name we are going to call the result. We'll use templates. This. Okay. So of course, first of all, we want to see how we need to implement this function, right? So function extract names, and then this is some sort of node, right? JavaScript node, JS node. So this function itself, we can check the type of the node, right? So switch JS node dot type. If it's a identifier, then we know that the name, we need to return an array, right? So here we probably will have to result equals to array, and then return, or rather we say a result dot push JSON node dot type, JSON node dot type dot, what is this? JSON node dot name. Yeah, real typing is slow, and a break, right? And then finally we return the result. So here we can console log result. And then for the binary expression, we will then look at either the left or the right, and then we recursively do it, right? Because if you take a look at here, if I try to do like counter times counter times counter, something like this, then you will realize that, oh, hold on, I need to console log JS node. Then you realize that this counter times counter times counter itself is a binary expression of a binary expression, right? So the left is a binary expression. So makes sense, right? Because this itself is, you can bracket this. So on the left, this is another binary expression, and then this is another binary expression. So we will recursively do that, recursively search and find all the variable names, right? So here we can call the JS node, call the extract names on the left as well as on the right. And then on the right, since it's identifier, it will return us the array. And then the left, it's a binary expressions again, and it will call recursively and then return us an array. And then finally, we need to combine all the arrays and then return as a final result. Something like this. Right, so we're gonna extract names, JS node.left, right. So these are result, right? So result.push. something like this, right? So here, and in the end, let me try and over here, let me try and print out all the names that we extracted. Names equals to names. Okay, so let's try and run. Oh, hold on. Console log names. So here we have counter. Here we have counter, counter, counter. Obviously, I mean, this needs to be need to get the unique set of elements, but it's still okay. I mean, we'll use in templates is a set, so we will add counter 3 times, but it's the same, right? So what's next? Well, we have to basically go through and figure out all the different kinds of expressions and then call extract names, handle different cases, different node types, right? Like call expressions. We could of course do that, but I trust you that I know after looking at this, you know how to do it, right? But one thing I want to point out is that this way of writing is not that optimized. I mean, it's good, but imagine here, every time when you call extract names, it returns a new, it creates a new array, returns that array, and then of course you will combine that array as you returns, and then return a new array, right? So if it's a very deep AS3, a very deep node, right? If you have like a lot of branches, then you will create the empty array a lot of times, right? I mean, yeah, empty arrays a lot of times, because if you come over here and then if this is 3 times 4 times 5, each of this, when you go in like binary expressions, you create an array. You go in here, you create an array. You go in here, you create an array, and then realize that actually 3 is a literal. It's like a number constant. It's not an expression. So you return an empty array. So this returns an empty array, this returns an empty array, and then you combine 2 empty arrays, and then you basically create a lot of arrays, intermediate arrays, to collect this, right? So there's a pattern of how to write this function. So this is how I'm gonna show you. Yeah, I'm gonna show you how you can write slightly better way of doing things, right? One way you can do is maybe when you go to extract names, you create an array, right? You create a result. And since array is mutable, you can pass in the reference of this result array. And then over here, you have this result array. And then you just keep pushing the results, right? You just keep pushing into the result array like this. And then you actually, whether or not returning the result, it's not really important, because in the end, you can come over here and get, you don't really care about results, you care about this array that you get, right? Of course, you can still do this, and you eventually return result, but this result itself, you don't really care as you go in a deeper recursion. But in the last one, when you first starting calling in, this is basically you are getting the same reference of the result, right? So this is the good direction, right? You pass in a result array, and then you're recursively calling, but you don't really create any intermediate arrays anymore. And then at any point of the node, you realize you need to push something, you push something on the result. And so the result itself is passed as a parameters. And because of pass by reference, you are always referring to the same result array. But doing this over here, it seems a bit ugly, right? You always have to create a result, and then you do this, and then you get the result, and then you access the results. And then actually this doesn't really matter, like you get the results over here and use it. But then you have to create this array. I mean, initially when I first write it, remember I was trying to do something like this, but this will not quite work anymore, right? Although it does because you return result. But like, what if we can write this without creating an array in advance, right? Or I mean, you can do this, right? Then this is that empty array that it passes in. I mean, we don't have to care about the result. I mean, we don't have to have a variables to hold on it, because extract names, we kind of do it in advance that we will return that reference, right? So it's the same array that takes in and then returns, right? So this is slightly better. But again, like doing this every time you have to create an array. I mean, calling extract names in the first time you have to call an array, and then subsequent times you are passing the same array down the recursion. So another way you can write is that if it's not passed in, you can default to empty array. Then in this case, you don't even have to pass this in anymore, and it will return that the first time it's undefined. You create an array, and then this array is being passed to all the recursions, and then in the end you return this arrays that you just created. So this and then you get it outside from here, and then this is nicely written, and you don't create intermediate arrays in the process, and it still works nicely. And if I console log name over here, hopefully you can see that it works by printing out counter. This is the first array, and then like this is counter for this tree, right? And if I have say counter times 5, actually times 2, I think that's more correct one. Then you see I have the first one is counter, and then this is counter, right? And if I have name, something like that, then this is counter and name. You don't have to create an array, multiple intermediate arrays, right? This is a very nice way of writing it. And I'm not sure whether you observe it, but as I was typing, the auto-completion tries to tell me that actually I can use periscopic. Just a so to remind you, periscopic is this library that we use to analyze the scope, right? We use to analyze the scope, and this actually has exports a function called extract names as well. This returns us a string array, so we can pass in this as well instead, and so that we don't have to implement ourselves. Hopefully when you go to extract names and you look at the implementation, like extract names over here, you can see identifiers. You can see a similar pattern, right? This is what we were kind of writing earlier on. We're handling, we handle the identifier as well as over here. We didn't handle binary expression. So I guess it's also extract names, but for a different use case. So if I try to run, let's see, probably it's not the right one. So let's just keep it as like our own implementation. But you can see this pattern. You can see this pattern is being used in libraries. So hope that you learned something. If you are new to writing like compilers or AST kind of stuff, this is one of the quite common pattern of trying to extract certain things within a node, AST node. So here, let's continue. We have basically we're able to extract now, right? We can mark it correctly. So even if we don't have this, we only have counters times 2. We are still able to see that let me collapse. Able to see that the counter is something that will be used, and you have to call lifecycle.update, right? Will be used within the template. And of course, let's take a look at the next thing is to how we handle the rendering of this node, right? Because if you run, you realize that this is undefined. This is because when we create our node, when we create our node, you realize that, let me run this code again. Okay. When we create our node, you realize that this is undefined, right? Why? Again, it's the same reason, because over here, when we try to write this, we're assuming that this there's two things, right? One is we're assuming when we create text node, we get these expressions. So we're assuming that this is identifier because we got that name, right? But this is incorrect. right? We need to better handle this. So expressions over here, instead of the name itself, we need, if it's binary expressions or something, we need to handle, right? We need to turn that into a string. And we know exactly a library that can turn a note into a string, which we have been using over here to do it for us, right? Which is the ES code gen, where we turns the JavaScript script in the script tag into a string. So we can use this, we can copy this and come over here. Text node over here, can take this and then expressions. Let's see, where are we using expressions? We're using here, right? So here, I think we can reuse this. We can say this node.expression. So we can take this, right? This is the expression string. Let's do camel case expression string. Okay, and then this over here, these two, we need to handle as well, because world change is checking it as if it's a binary, as if it's a identifier, right? So if I try to run our code, realize that we got half of it correct now, right? Here we generated correctly, but here we haven't updated because we are treating name it as an identifier and check whether this node itself, the counter times 2, as an identifier, and then we check whether it will change. But I mean, counters times 2 itself, it's not a variable or name that you can do, right? We want to extract the counter out, and then we check, okay, whether the counter or any of the variables being used within that has changed, right? So we can do that by extract it out again. Names equals to counter, sorry, not counter, but extract names. Extract names node.expression, and then names. So names, we will loop through names as long as we have one name that has changed, then we will say that it is will needs to update. And here and includes over here the place where we do the check. I mean, let's run this first, and then you will see what I'm trying to refer to. Right now we add another line. Right here it's correct. Now we have this line will change, but this includes this thing. It's I mean, it's not quite correct, right? We want to only have like counter. But if you have multiple expressions, right? So for example, if I try to declare double equals to 0, and then counter times double, something like this. We want to be able to extract like counter, and that the change includes counter and includes double, and then we do something. Right? Of course, I mean, double is not something we'll change. We don't have to include them. Right. So first is to convert. I mean, the names is already giving us the double and the double and counter, right? So we just need to change that over here. So I'm gonna change it to something like .has .sum name includes name. Same thing, because it's array, we handle it this way. Oh, let me see whether if I'm missing any brackets. No, okay. And this over here, actually we can replace it with names, JSON.stringify names, right? Because it's if this name is an array of strings like A, B, C, I mean the JSON stringify version is still JavaScript code that we can put it over here. So let's try and run this again. And let's take a look. yeah, we have this, and then dot sum name includes this thing. But then we realize that double, I mean, double will never be inside change because we never change double at all, right? In fact, if you try to see if this is just double times double, you'll realize that we don't even have that line at all because double is not something that will ever be changed. So we need to handle that case as well. But I guess it's just work that needs to be put in. I believe you know how you're going to change it, right? Let me try and think about it, and let me quickly write it out. I think we can have changes equals to a new set, right? Of, and then for changes for sorry, the names dot, so names, we go through each name, and if the name is in here, right? If it's in here, has name, then we're gonna add it to changes name. Right, and then with that, here this changes is a set that we can stringify instead of names, right? So this only will filter out those that has as name. And yeah, I probably should have used filter as well, but anyway, nonetheless, from names, and let's try run this. Sorry. And here you see, okay, we didn't change counter, but I mean, if I have this, then here you will see that, hold on, counter double will change. Oh no, this is from changes. And here you see that we only have counter itself, right? And actually, if you know, I mean, if we can handle this like counter, then if we know that it's only one element, then we don't have to use the sum, right? I mean, the code itself can be optimized in a lot of ways. The output of code, that's what makes Svelte so amazing, is that you can always optimize. You can always think about how to optimize this code itself, the output code itself, so that it's small, right? So for example, I can say like condition, if changes dot size is greater than 0, like greater than 1, then the condition is equals to like this one. Okay, and else the condition is equals to like this, changes includes, oops, change includes name, something like this, where this one is the changes, like the first element of this one, and then here we can have the condition, right? And if you write this, if you run this, see that now it's simpler. But as soon as you try to maybe double plus plus, something like this, if you try to do this, then you realize that it turns into a more efficient, more complex one. So you have this, you always try to strive to get the minimal, more optimized JavaScript code to run so that it's simpler, right? So here, I think we handle it nicely already. So if you try to refresh this page, hold on, the double, I mean, let's just do this first. Build our code. Here, I believe this is the latest output and we are importing from it, right? So let's refresh. Now, oops, something is not quite right. Let's take a look at the output. Wait, no. Hold on, what's causing the problem? Oh, this should be string itself. Yeah, sorry. My bad. Um, Forgot about this. So here it's correct, but this one it should be a string itself. Like this. Right? Let's try and build again. Now this will work, right? Now you support expressions, any kind of expressions. So I mean, as an homework, I'm not gonna do it for you, but you can try to handle call expressions, something like this, right? A foo. Value times value, something like this. Okay, if you try to run this code again, you probably will see the output. It's not really quite handled well. In terms of the updates, right? Because we didn't really check in terms of whether I think we can't find all the names that we can't extract the names, the variables that's involved over here, and then that's why we don't really know like whether like foo is being used in templates and things like that, right? So this is a homework for you to go and figure that out. In the meantime, and if you like, you can definitely make a pull request to the repo. Okay. And now we also want to handle one more thing that I didn't really handle well. Right here we do counter equal plus plus and but if you do counter plus equals to 1 like this, I realize that this doesn't work. Okay, I'm not extracting, not updating, not doing anything at all. Well, that's because we only have handle update expression. And if you look at this node, if you're trying to find it, this is called an assignment expression, right? So node.type equals to assignment expression. So either update expression or assignment expressions, we need to do something. And if you take a look over here, node argument name, well, again, argument is something for update expression, right? If you try to take a look at the AST using AST Explorer, and we write counter plus equals 1, and you can see that this expression itself is an assignment expression, and then it has left and right. There's no argument. If you go to this one, update expressions, that's where you get the arguments, right? So we need to handle it differently, right? So it's either equals or this one. So you can check the type to handle them, or I believe this is where you can use the periscopic dot extract names to do so, right? So this gives you a list of names, and then I mean, let's see. Let me just comment this out and console log names. Okay, let me try and run. Oops. Remove this one. Okay, this gives me empty. Okay, which means I actually have to write something. I thought this would help me with my problem. So let's see. Hold on. If dot. What's this again? What's this extract names doing again? Okay. I think it helps somewhat. In terms of extracting the names, but we need to pass the left side or the argument. We need to pass this or this for it. you might think, oh, but why? Then what's the point of periscopic? I think when you try to do destructuring, for example, like uh, oops, something like this. If you do something like this, where left is an object pattern, then right, left is an object pattern. Sorry, I switched too fast. Then if you look at the periscopic extract names implementation, it does handles object patterns and try to extract the value, right? But it doesn't really handle assignment expression. So I guess we need to pass this left side to periscopic, or the argument to periscopic to figure that out, right? So if you do something like c dot b, a dot c dot b, this is a member expression, then also periscopic does handle member expression and extracts the object out. So here, I guess we will have to do that ourselves. If we check this, and then I guess the node itself maybe dot type equals to update expression, then it's the node dot argument, or else it's the node dot left, right? And then we use the names. So if I run this now, see that it extracted counter. And if I change over here app.svelte, if I change like say a.b.c, or maybe like this one, destructuring ABC, sorry, maybe try different name, DEF, then you can see that it extracts A as the object, right? Because you're just modifying A. And in this case, DEF is this tree, which is correct, right? We are changing D, E, and F. Revert this first. Once we find that, then we will have to come over here, go for each names, find whether they are whether they are in the root scope, and then we're gonna add them, right? So for I think this is the replacement part. I think let's copy this first. So we have a similar code. Remember, we have similar code to do this once, and where we do the analysis, where we will add into the world change, and then the next one is we were in this place where we're trying to generate a code where we go through the same expressions again, and then we try to insert the lifecycle update kind of function, right? So I think we KIV for this for now. Let's go up and up to where we determine what will change. So here, let me copy the code in. So here we check, we get the name, and then we check. So for each one, I think this is what I'm gonna do. So for names, for each variable name of name, I'm gonna check if this name, whether the scope we declare it is the root scope. Then if so, then we're gonna add it to the world change, and that's it. Voila. But if we come back to the part where we generate the code, over here we will, all we need to do is to figure out what are the variables, right? Which are the variables we will be updating, and then figure out whether they will be being used, and if so, we're gonna update and insert this lifecycle update method, right? So the way we're gonna do is we're gonna filter out. So with the names, I think over here we do have names. Then I'm gonna filter out name, where if the name is, if this, right? If it's, and then also if it's, and also if analysis will use in template has this name. Because it's name instead of the argument.name. Right? If so, then we are gonna use it. We're gonna add it. So I think we just return this value over here like this. So let's try run again. You see that we still have printing out counter. But if I try to say come over here and a dot b dot c equals 3, de equals 4, okay, something like that, then in my code, when we try and run, then we don't get anything, right? Because you're not modifying something that will change. But if you say counter.a.b.c, then counter is considered modifying counter, right? Although, like, this is gonna be throwing some error, but nonetheless, we are trying to modify counter. So we get this list of array, this list of variables that will change. And over here, we are going to say names. If names.length is greater than 0, then we're gonna make changes and insert that lifecycle updates kind of thing, right? So I think over here we can already move this up and uncomment it, and then leave this untouched. All right, I think this makes sense. And then over here, this array, again, we've seen so far, what we do is we're gonna JSON stringify the names. Let's try run again. Now, if you take a look at the code, we have here counter, then we will update counter. And this one we don't insert, this one we do, right? And if I try to change, say, double and counter equals to something like this, and then if I run, then you'll take a look here is that I will change double and counter, and then I update, double and counter. Double is not used in the template, right? So if I'm using double in the template, then you see that after this, we are going to do this, right? We are going to update double and counter at the same time. So that's great. So now with that in place, we are going to, I think there's nothing much. We're gonna fix this code over here a bit, like this, right? So this is a valid code. Simplify a bit, or maybe we want to have count double equals to 0, double plus equals to 2, and over here I can say counter minus minus, and then double equals to counter times 2, just to throw in some flavor. Now if I run, this is the code that it generates. No double. Because we are not using double over here, so double as well. Now we are doing this, okay, and then counter double, okay. Over here we are, I think the output looks correct, right? We have counter this one, and double update this text, update 3 different texts. I feel that we are ready, so let's take a run on this. We refresh this. Okay, this is counts times 2, and this is double, right? This is double. If I increment, you see that we are incrementing it correctly, and if we decrement, it works fine as well. So here you have it. We have our first improvement. We handle different kinds of expressions, as like this one and this, and then we also able to handle different kind of not just update assignments, update expressions. We also handle the assignment expressions. So what's next? There's a lot of next, right? So the next thing we're gonna do is, double over here. It's not look good, right? Let's try to support a declarative assignment, something like this, where now every time counter changes, you update double as well. If I run this code now, I mean, this will be just another, statement that does nothing. It will run once, but then this is just a normal label. It does not have the reactive declaration feature that we know of. So I'm gonna see you in the next video, right? So if you like this video, give me a thumbs up. If you have anything to ask, comments in the section below, and I'll see you next one. Bye bye.